matrices and equation in school? Well, I'm here to show you how this fundamental knowledge forms the backbone of machine learning, data science, neural networks, deep learning, and AI. So let's begin with simultaneous equation. So as we have been taught, let's say we have x and y at the left hand side and then 5 and 1 at the right hand side. If we rearrange the x and y, we take the y from left hand side to right hand side, we can substitute it into another equation. So now we can get y equal to 2, x equal to 3. Let's say we refer to the same equation again, but this round we do it using 2 by 2 matrix method. So we can take out the x and y. We have the equation re-represent in the matrix form. Now we have ax equal to b. So in order to solve x, we are going to multiply it with inverse of a both sides so that we get x equal to inverse of a multiplied with b. How to get the inverse of a? We compare this a, b, c, and d position with the coefficient matrix. Then we find the determinant of a first. After that, we get the adjugate of a. Then we can get the inverse of a and we multiply it to the b. Eventually, we get x equal to 3, y equal to 2. So you can solve this using the Python NumPy also. But now we move forward with 3 equations and 3 variables. Let's say we have x, y, and z, and then equal to 5, 1, and 11 respectively. So by using elimination method, we eliminate the z first. Now we left with x and y. So we solve x and y. After that, we substitute it back to either one equation. We will get the z. So at the end, y equal to 2.5, x equal to 1.7, z equal to 1. So again, we try to solve this simultaneous equation using the matrix method also, but this round 3 by 3. So how to solve 3 by 3? How to find the inverse of a of 3 by 3 matrix? You might learn partitioning or you might learn row reduction method, but it doesn't matter because in real world we are not going to have only 3 by 3 matrix. We are going to have n by n or m by n. So the finding of inverse matrix will be done inside a software, whether it is R, Python, or any software that you use. So I just want to show you from 2 by 2 to 3 by 3, you can find and solve the simultaneous equation using matrix method. So now we progress into regression. So in regression, we want to find the best fitting beta, the coefficient such as x beta predict the y. So you may recall the linear regression y equal mx plus c, which is a straight line. You can find the gradient m, which for the line of best fit. In regression model, we have x1, x2 up to xp. As I said, in real world data, we have n times n or m times n. So we can take out the beta. Now the equation become x multiple beta. And you can realize that the xb equal y is just an extension of ax equal b. Let's get an example data set with numbers so that we can understand what I try to illustrate. Let's say we have house price and then square foot and number of room. You see, for the same number of room, the bigger house is more expensive, which is logic, makes sense. Now we represent the data in x, which is the input data, and y, which is the output data, or you can say it is dependent variables. Now we want to find the beta, which we said we try to train the data to get the model. In data science, we always said we train the data. So we try to find the beta so that we get a y equal to beta, which is a constant, and then a beta multiplied with x, which is the input data. Eventually, we can use the model to predict the y. ask why to find the beta, the formula seems so difficult or complicated compared to the simultaneous equation. Yes, because we are not solving the simultaneous equation. In this regression, we are trying to find the beta coefficient, which will later form the regression model. So there are many linear algebra proving going behind, even the derivative of matrix. If you learn about dy dx, usually we learn how to solve the equation, but now derivative on a matrix to find the minimum of error. So the beta is being derived using the least square method. So again, you no need to know so many theory behind, because the Python or R will handle this for you. If you want to read further, you can read my notebook. Just click the link in the description below and it will take you to a form where you can provide your email address. After that, you can make a copy of this notebook and play around with it. That's all for today, and see you next time.